Okay, so the next speaker is Szabolcs Molnár, who is also member of the WSC Lab group working with us. And Sabi will speak about the toolbox for high energy physics and the sustainability of the high energy physics event generators. So Sabi, the stage is yours.
Yes, thank you. So first of all, I would like to introduce Docker and what it is and why it is important. Then I will move on to Monte Carlo event generators, just a brief introduction, and after that I will talk about the toolbox which we created and some of the results. After that, the sustainability of event generators, the optimization results, some of the tuning results which we achieved by using the toolbox, and a brief tutorial at the end. So Docker is essentially an open source platform for containerization. It is important because it contains the application that one would use with all its dependencies, runtime, libraries, and so on. And it shares the host operating system's kernel, and that makes it a lot faster than a virtual machine would be. It also creates an isolated environment, which means that if we use a Docker image and create a container based on that, then whatever we change in the container will not affect the host operating system or the Docker image. And it is also declarative and reproducible and works with Kubernetes. As for Monte Carlo event generators, the Hygiene++ in general, which is a heavy ion jet interaction event generator written in C++. Monte Carlo event generators simulate the complete evolution of particle collisions, and Hygiene++ in particular is written in C++ and has built-in CPU parallelization, which will be important later. Overall, these event generators need a lot of computational power, and because of that, they require optimization, especially nowadays that the high luminosity era of the LHC is approaching. These event generators usually also have to be tuned, the parameters of the generators, I mean, and for instance, there is the Monash tune of PTI 8. Now, the toolbox that we created, well, it's named based on the professor, which is the tuning tool, the Rivet and the PTIA. It is based on Ubuntu 22 LTS for now. It is 100% open source. We have plans to create a rolling release image version, which is based on Arch Linux. And well, it has multiple packages built in that work out of the box, as well as code compilers. Sorry, that's a mistake. And the GNU debugger. Well, we created an SSH version of this Docker image, which can be integrated with the VS Code. The latest version is 4.4. And well, initially it was a project to make the tuning and debugging of Hygiene++ more convenient, but now it has over 1,300 downloads from Docker Hub. We used this to benchmark certain CPUs. It has a benchmarking script included from the 4.4 version. And overall, we tested the CPU power consumption and the overall impact of parallelization on the runtime for 500,000 proton-proton events and 10,000 heavy ion events. From these 5 investigative CPUs, I will present the result of the last one in more detail. So first of all, we have the runtimes for each thread. So we tested with the parallelization from 2 to 16 threads, and of course the single thread mode. Up here we can see the runtime for proton-proton events and below the heavy ion events. Then from that we can calculate the event per second, so the speed of the given thread. And we also measured the power consumption per thread, and sorry, the speed of the heavy ion case. So the maximum of that was 10.8 events per second, and also the power consumption related to that. So sustainability-wise, it is important because we have to optimize the in terms of the speed and the power consumption. So we introduce a metric, essentially the cost of each event, and overall these results were interesting. So first of all, there was the no write mode, which it's just a reference. It tests the speed of the CPU. In a better case, usually we have HDDs. This shows the cost of the events was the least around 3 threads, and the one which we tested mostly was with the SSD. The previous plot was for the SSD results. The error on these plots comes from the power consumption measurement because the power was measured each second, and the error comes from that. And also these optimal results don't mean the fastest, so it only means the least cost. And overall, we saw a significant improvement over a single thread mode in the case of Hygiene++, and usually at the fastest and most optimal thread counts, we saw a reduction in runtime from 25 to 51%. And power consumption wise, the most optimal case was 7% reduction in power consumption. But these are very simplified estimates because this only includes the runtime, so the event generator, and not the subsequent pre-wet analysis or the professor, which is used for the tuning. In the case of heavy ion collisions, the power consumption would be roughly 140 to 180 times more because of how much slower that runs. And these results were calculated with 1,024 configs for 5 million events each, 10 iterations, and 6 energies. So the overall tuning cost is 7% or roughly 7% reduced. I would like to present the recent tuning results of Hygiene++. The toolbox that we used made the process very convenient because everything worked out of the box. And here we can see the pseudo rapidity distributions from the tuning. Pseudo rapidity is used to measure the angle of the particle's trajectory relative to the beam. And well, usually before we had this toolbox, we had to install every tool on its own, and the dependencies usually conflicted. So it was very inconvenient without the toolbox. And as for the usage, we have a tutorial available on GitHub, or shortly it will be available. For downloading the image, it's a simple Docker pull command, assuming that you have the Docker installed already. As for running the containers, you can attach any folder to the container and run it in interactive terminal mode. If you have a container already running, but you don't have an interactive terminal, you can simply run this command to execute this, essentially a bash command, which will give you an interactive terminal. As for the SSH version, it has the 1779 port open. It is only accessible through that, and the IP address of the image can be you can see it from the Docker inspect command overall. For I wanted to talk a bit more about this plot, because in the case of the other CPUs, just for comparison, we, for instance, the Intel Xeon E5-2650 had, and the older EPIC versions had the second thread as the lowest in terms of runtime, despite the parallelization, and the fastest thread was, in this case, the 15th for the proton-proton events, and interestingly, the 4th for the heavy ion events. As conclusion, so this Docker image is essentially a tool to make these processes a lot easier, more convenient. For the benchmarking, well, both scripts are included in the Docker image, and as we could see from the results, the newer CPUs are a lot more efficient for these tasks and a lot more optimizable. Well, we are working on a publication for this toolbox, which will be available on arXiv and the European Physics Journal as well. Well, that's all I want to tell.
Okay, let's thank Sabi. Question to Szabolcs.
Hi, thank you for the nice talk. So my question is that there is this other containerization library, I don't know, called Singularity for HPC computations. And you use Docker. So what is the difference? And why didn't you use Singularity? Or is that a niche thing? Or do you know about this?
Well, actually, we didn't consider that. I'm not really familiar with that. We only worked on Docker because, well, that was more convenient for us.
Okay, thank you.
Thanks for the tip.
Hi, thanks for the talk. I had just a quick question. Because I know that if you have software that runs on EPIC CPUs, there are some special compile flags, at least in like C++, that allows you to utilize AVX more. Is that also probably used there?
You mean the, sorry, can you repeat the first part of the?
Oh, yeah, so there's some special tuning flags to properly use like SIMD instructions on EPIC CPUs. Is that also like utilized here, or?
Well, in the case of this, the CPU that I presented, I would assume that it had an impact, but we didn't include that on purpose. So, thanks.